In this video, we are going to take a look if the force that's given there is conservative, and by the way, it has only two components. And if yes, I'm going to show you how to find the potential for this force. Okay, so in order to figure out if a force in 2D is conservative, suppose it has two components, P and Q. We want to take the partial derivative of P with respect to Y and make sure that the partial derivative of Q with respect to X is the same. Okay, let's see if that's correct. So P with respect to Y was going to be, okay, so e to the x, y to the 5. E to the x with respect to y is just a number, so it's a constant multiple, and we keep it. And then derivative of y to the 5, according to the power rule, is 5y to the 4th. So we're just going to put 5 in front, y to the 4th. There you go. Then minus derivative of 5y with respect to y is just 5. Okay, q with respect to x. So 5 is a number. And with respect to x, y to the 4th is also a number. So we keep it as a constant multiple. And derivative of e to the x stays the same. So this part actually just stays the same. Minus derivative of 5x with respect to x, and that's a 5. So when we look at these two, they are the same. And that means check it's conservative. So let's just type that here. And we made sure that, yes, it's equal. Well, I could have just copy pasted. Okay, well, it's okay. So the next thing is to find the potential. Now, the force is conservative when it's the gradient of something. And that's something we need to find. So look at what happens. First of all, the forces, components of the force are P and Q. And components of the gradient of that unknown function that we're trying to find is fx, fy. So what that means is we need to find a function such as the partial derivative of it with respect to x is equal to p, and the partial derivative of it with respect to y is equal to q. Okay, so let's see how to find that. Well, to undo the derivative, we usually integrate, but this time we're going to partially integrate. So to solve, since we know that p is f of fx, we're going to take an integral with respect to x, and that should give us our potential, right? Okay, so let's see if we can do that. So take the p, which is e to the x, y to the 5, minus 5y, and we integrate that with respect to x. So e to the x, y to the 5. Well, y to the 5 is a constant multiple, so we keep it. And e to the x stays the same whether it's derivative or integral. Okay, minus 5y with respect to x. So think of it as like number, integrating a number with respect to x would be like number x. So this would be 5yx or 5xy. And that's the potential, right? Well, not quite. Here's why. Whenever you integrate, I don't know if you remember, but usually you put something like plus c, right? And so here it's going to be actually the same thing. You're going to have to put plus c. And because you were partially integrating with respect to x and treating y as a number, this c, I will call it c1, could actually have y in it. Okay? So yes, we found the potential, but we might be missing a term that only contains y. So we're going to have to do the second half. What is the second half? Well, since our function or vector field PQ has to be equal to fx, fy, we can also say that q is fy. And so to solve for f, we can integrate q with respect to y now. And we should also get f, right? So that's going to allow us to pick up that extra term that we may have missed when we just did the partial with respect to x only. Okay, or integrated with respect to x only. So let's take the q and let's integrate that with respect to x. I'm sorry, with respect to y. I'm sorry, with respect to y. Okay, so with respect to y, let's look at this term. So 5 is a number, e to the x is a number. Okay, let's keep that. Y to the 4th integral is going to be 1/5 y to the 5. Remember, we add 1 to the power, and then we divide by the same thing. So notice how 5 will cancel. And then we're also going to have minus 5x with respect to y. That's 5xy. And again, here we could have plus c, but this one could have an x in it. So maybe we are missing a term that has an x. Now, what I want you to do is compare the two answers. It must be the same. So do you have a mixed term? Mixed term is a term that has both x and y variables. And yes, I have it. And it is also in here. And notice how once I canceled the 5 and 1/5, the mixed term is actually the same. If that did not happen, you are in trouble because there is no way to fix that. So if the mixed terms are not the same, that's a problem because these two have to give you the exact same answer. Now we have also the same exact situation with this part, which is also a mixed term, and that matches. So that's great because if it didn't, that means that your force was actually not conservative. You didn't do the check correctly. So same also. And we did not have any function that has only y and only x whenever we integrate it. So that part will just be 0. So we don't have that. So in conclusion, our potential is going to be e to the power x, y to the power 5, minus 5xy. I always encourage you to check your answer by taking and comparing what happens if I take the partial of this with respect to x. Do I get this component, the first component of the force? And if I take the partial derivative of this with respect to y, do I get the second component? And the answer is yes, so you did it right.